It's committed to ensuring that injustices prevalent in Western Sahara are brought to an end and the conflict there is resolved.
One of the driest places on Earth has flooded for the first time in half a century.
Beneath the endless golden dunes of the Sahara Desert, an expanse that stretches across much of northern Africa and appears lifeless to the untrained eye, scientists have recently uncovered something that challenges everything once believed about this vast arid region. The Sahara has long been a symbol of desolation, a place where survival itself is an act of defiance against nature's extremes. Yet hidden far below the surface lies evidence that this harsh desert was once a cradle of fertility, a living landscape teeming with life, water, and ancient human ingenuity. What has come to light beneath the Sahara doesn't merely alter our understanding of the desert's past, it reshapes humanity's perception of how civilizations and ecosystems evolve, thrive, and vanish over millennia. Before we start, hit the like and subscribe buttons for more updates. The discovery began as part of a collaborative geological survey designed to map subsurface structures in North Africa. Using advanced satellite imaging, radar technology, and deep penetrating ground sensors, scientists detected vast anomalies buried thousands of feet beneath the sands. What initially appeared to be natural formations soon revealed geometric patterns, river channels, and circular depressions too deliberate to be random. As teams from multiple nations converged on the findings, they realized they were peering into a forgotten chapter of Earth's environmental history, a world hidden in plain sight. One of the most astonishing revelations came when radar imagery uncovered the traces of an immense ancient river system coursing through what is now a sea of dunes. This river, wider than the Nile in its prime, once flowed from the central highlands of Africa toward the Mediterranean, linking lush savannas, wetlands, and fertile plains. Its banks would have supported thriving ecosystems filled with wildlife, elephants, hippos, crocodiles, and the earliest humans who followed the water's bounty. The discovery of fossilized riverbeds and floodplains under the Sahara paints a vivid picture of a continent that was once green and abundant, its climate radically different from the scorching desert of today. Deeper excavation revealed something even more compelling. Hidden beneath layers of sandstone and compacted silt were remnants of stone structures, patterns suggesting settlements or ceremonial complexes. These were not random piles of rock, but organized foundations, evidence of human activity stretching back tens of thousands of years. Some formations appeared to be aligned with celestial points, much like ancient monuments elsewhere in the world. It became clear that early civilizations had not merely passed through the Sahara. They had lived and thrived there during an epoch when the region was fertile and alive. Archaeologists working alongside geologists soon identified what they believe were agricultural terraces, irrigation channels, and the remains of storage pits. The precision of these constructions implies a deep understanding of water management and seasonal cycles. These were not nomadic tribes scraping out an existence. They were communities rooted in a landscape that supported sustained growth. As sediment analysis continued, microscopic pollen samples told their own story. The Sahara was once covered in grasslands, dotted with forests and lakes that sustained rich biodiversity. Equally transformative was the discovery of the so-called Mega Lake Chad, an ancient inland sea that, at its peak, stretched across hundreds of thousands of square kilometers. Once believed to be a myth or exaggeration, it was confirmed through satellite imaging that traces of its shoreline and sediment layers remain buried under centuries of shifting sands. The existence of such a massive water body in what is now one of the driest regions on Earth challenges the narrative of the Sahara as an eternal desert. It suggests that the region underwent dramatic climatic shifts, possibly triggered by changes in Earth's tilt, atmospheric circulation, or human-induced deforestation thousands of years ago. The implications of these discoveries extend beyond Africa. Understanding how the Sahara transformed from lush savanna to lifeless desert could help scientists predict the future of other regions threatened by desertification today. Climate models are already being recalibrated based on new data extracted from Sahara sediments. Ancient pollen, isotopes, and mineral compositions provide a window into how rainfall patterns shifted and how ecosystems collapsed or adapted. What happened to the Sahara may hold the key to understanding how modern climate change might reshape entire continents. Another element that astonished researchers was the detection of vast freshwater aquifers trapped beneath the desert's surface. These underground reservoirs, some of the largest on Earth, contain ancient water, remnants of the humid period that once sustained the Sahara's lakes and rivers. The Nubian sandstone aquifer system, one of the most studied, holds enough water to support millions for generations. Yet tapping into it presents both opportunity and risk. Over-extraction could destabilize delicate underground systems and accelerate desertification. Still, for nations bordering the Sahara, this discovery could represent hope, an untapped lifeline in a region long plagued by drought and scarcity. Within these aquifers, scientists also found signs of microbial life, extremophiles capable of surviving in high-pressure, low-nutrient environments sealed away from sunlight for millennia. Studying these organisms has sparked interest from astrobiologists who see parallels between such subterranean ecosystems and what might exist on Mars or beneath the icy crusts of Europa and Enceladus. The Sahara, it turns out, may serve as a terrestrial model for understanding life beyond Earth. But perhaps the most thrilling and controversial discovery of all lies in the realm of anthropology. As researchers analyzed buried artifacts, engravings, and bones found near ancient water systems, they unearthed evidence that human migration across Africa was far more complex than previously thought. The Sahara, once considered an impassable barrier, might instead have been a thriving corridor connecting populations across the continent. Genetic data from ancient remains indicate that early humans used the Sahara as a highway of sorts, spreading technologies, languages, and culture across Africa and beyond. Stone tools, petroglyphs, and fragments of pottery point toward an advanced prehistoric culture with knowledge of metallurgy and astronomy. Some engravings depict animals long extinct in the region, giraffes, lions, and even aquatic creatures, capturing moments from a forgotten ecosystem. The artistry of these works suggests not only survival, but a flourishing of creativity and observation, linking the ancient Saharans to early civilizations that would later rise along the Nile and beyond. What shocks the scientific community most is how rapidly this transformation from green paradise to barren wasteland occurred. Evidence suggests that within just a few thousand years, the Sahara flipped from humid to hyper-arid. The process may have been influenced by subtle shifts in Earth's orbit and axial tilt, altering monsoon patterns. Vegetation loss would have accelerated heat absorption, drying the land even further. The rapid pace of change is both awe-inspiring and terrifying, a testament to nature's power to reshape entire worlds in a geological instant. As sediment layers are peeled away, researchers are finding evidence of megafauna extinctions, mass die-offs of species unable to adapt to the drying environment. Fossil records show elephants, antelopes, and even aquatic mammals once roamed or swam through what is now empty desert. The shift forced human populations to migrate toward remaining rivers and oases, setting off waves of movement that would eventually populate the Nile Valley, the Maghreb, and sub-Saharan regions. In this sense, the Sahara's death may have given birth to civilization elsewhere. The magnetic and gravitational anomalies detected beneath the desert add yet another layer of intrigue. These signals suggest the presence of massive subsurface structures, possibly ancient tectonic features or remnants of meteor impacts. One particularly striking circular formation buried under the Western Sahara, known as the Richat structure or the Eye of the Sahara, has long puzzled geologists. Once thought to be an impact crater, recent findings propose it may be the eroded remains of a gigantic uplifted dome formed by ancient volcanic activity. The surrounding layers, rich in minerals and fossils, further testify to the region's dynamic geological past. Alongside natural wonders, scientists also identified evidence of mining activity in certain regions dating back tens of thousands of years. This suggests that early humans not only inhabited the Sahara, but also exploited its mineral wealth, perhaps extracting hematite and other ores used for pigments or tools. Some of the world's earliest examples of pigment use may have originated here, linking the Sahara's ancient inhabitants to the global story of human innovation. While many questions remain unanswered, one thing has become certain: the Sahara is not merely a desert, but a vast time capsule preserving eons of Earth's transformations. Every layer of sand conceals a narrative, from the first rains that sculpted its valleys to the civilizations that flourished beside vanished rivers. The depth of these discoveries is rewriting textbooks and sparking debates about how climate, geography, and humanity are intertwined. Geologists have also begun to map extensive cave systems and underground formations beneath the dunes. These cavities, some filled with fossilized remains and mineral deposits, may hold clues to how the desert adapted to fluctuating climates. The presence of stalactites and mineral crusts indicates that water once flowed freely through these spaces. Each newly discovered chamber adds another fragment to the mosaic of the Sahara's ancient story. A world where abundance once reigned, where now only silence persists. The use of advanced satellite radar, originally designed for space missions, has been key in unveiling this buried world. By sending pulses through the sand and analyzing reflections, scientists can reconstruct 3D maps of ancient landscapes hidden below. These visualizations reveal former river deltas, mountain ridges, and even shorelines, like ghostly fingerprints of a vanished Earth. To see such vivid traces of life beneath what seems to be lifeless terrain stirs a deep sense of wonder, reminding humanity of nature's ability to both create and erase. The rediscovery of this ancient landscape also reframes our understanding of African prehistory. For centuries, narratives of early human civilization have been centered around the Fertile Crescent and the Nile Valley. Yet the Sahara's newly revealed history suggests that Africa's interior may have been just as crucial in shaping early human development. The tools and artifacts found there indicate complex social structures, trade routes, and cultural expressions predating many recognized civilizations. This shifts the spotlight back to Africa as the true heart of early innovation, exploration, and adaptation. Furthermore, the chemical composition of sediment layers has provided insight into global climate interactions. Traces of volcanic ash and marine particles suggest that the Sahara's climate was influenced not only by regional changes but also by distant events, volcanic eruptions, ocean currents, and atmospheric shifts. The desert, in essence, serves as a natural archive, recording global events across tens of thousands of years. Each grain of sand tells a story of wind, water, and time. Scientists are now using this data to reconstruct models of the planet's past climates, offering parallels to modern environmental trends. The Sahara's transition from a lush green expanse to a barren desert is one of the most dramatic examples of natural climate change in Earth's history. Understanding how and why it happened could help prevent similar ecological collapses in vulnerable regions today. As the planet faces rising temperatures, expanding deserts, and shifting rainfall patterns, the Sahara's buried past has become a lesson in both survival and caution. The scale of what lies beneath the Sahara defies imagination. In some areas, layers of sediment preserve traces of lakes so large they could have rivaled inland seas. In others, fossilized coral reefs suggest that parts of the desert were once underwater, linked to ancient oceans that have long since receded. These findings reveal a dynamic environment that has transformed repeatedly over geological time, alternating between lush and barren phases. Each cycle of renewal and decline has left its mark, etched into the very bones of the earth. Among the most captivating findings are the remnants of ancient flora, microscopic impressions of leaves, seeds, and pollen preserved in sediment. These tiny relics speak of forests filled with acacias, palms, and grasses. The diversity of plant life indicates that the Sahara once supported ecosystems similar to today's savannas of East Africa. Such environments would have been ideal for early human life, providing both sustenance and raw materials for shelter, tools, and art. The idea that beneath one of the harshest environments on Earth lies the memory of a paradise evokes both awe and melancholy. It forces a reevaluation of what deserts truly are. Not lifeless voids, but stages in a planetary drama of transformation. The Sahara's hidden rivers and ruins reveal that even the most desolate landscapes once pulsed with life, and perhaps could again. The same geological forces that erased that world may one day revive it, if climate cycles shift once more. The technological implications of these findings are also profound. The techniques developed to scan the Sahara's subsurface are now being adapted for other uses, locating hidden water reserves, ancient settlements, and mineral deposits worldwide. By studying the Sahara's buried world, scientists are refining tools that could revolutionize resource management and archaeological exploration. What began as an investigation into the desert's past has become a frontier of innovation for the future. Every expedition into the Sahara's depths reveals new mysteries. The discovery of fossilized fish in regions hundreds of miles from any modern water source raises questions about how quickly the landscape transformed. The identification of shorelines from vanished lakes provides evidence of catastrophic floods and massive hydrological shifts. The deeper researchers dig, the clearer it becomes that the Sahara's past was not static, but alive with change, motion, and story. In regions like the Tadrart Akakos and Tassili N'Ajjer, cave paintings depict scenes of daily life from this lost era. Hunters chasing gazelles, families beside rivers, herders with cattle grazing on green pastures. These artworks serve as the Sahara's diary, capturing in pigment the life that once flourished there. When compared with geological data, these images align perfectly with the timeline of the Green Sahara period, confirming that this was no myth but a living reality. Beyond the human and environmental aspects, there is also the geological enigma of what lies even deeper. Some teams have suggested that buried under the sands are mineral formations rich in rare earth elements and metals formed under ancient tectonic pressures. This discovery has geopolitical implications, as such resources could become vital for future technologies. However, accessing them would require balancing the pursuit of progress with preservation of an irreplaceable natural archive. The Sahara's buried history also opens philosophical questions about permanence and change. Civilizations rise, climates shift, and landscapes evolve beyond recognition, yet traces of their existence endure, waiting to be found. Beneath every barren plain may lie the ruins of a forgotten world. The Sahara, in this sense, becomes not just a physical place, but a symbol of the Earth's memory, an ancient ledger written in sand and stone. Beneath the sweeping sands of the Sahara, scientists continue to peel back layers of mystery that stretch far beyond what was first imagined. The desert's seemingly infinite dunes conceal not only the fossilized remains of rivers and civilizations, but also deeper geological and biological secrets that reach back millions of years. Each discovery opens another chapter of the planet's story, an epic of transformation, extinction, and survival written into the bones of the Earth itself. The ongoing excavations and analyses reveal that the Sahara is not a static landscape of desolation. It is a living archive of Earth's evolution, a witness to epochs of unimaginable abundance and equally profound collapse. What researchers are now uncovering goes well beyond environmental transitions. It touches on the very origins of continental shifts, hidden energy reserves, and the buried record of cosmic events that once shaped the face of northern Africa. With new layers of exploration, scientists are beginning to see that the Sahara was not merely a lush expanse that turned dry. It may have been a pivot point for continental weather systems, a pulse in the heart of the planet's climate engine. The forces that built and buried the Sahara's ancient rivers, forests, and lakes are the same forces that sculpted the continents themselves. Beneath its sand lies a geological history that could alter our understanding of how Africa evolved, and by extension, how life adapted to those changes. Seismic surveys conducted across the desert have revealed deep fault lines and tectonic scars running beneath the dunes, remnants of ancient continental collisions that date back hundreds of millions of years. These fractures tell of a time when Africa was part of the supercontinent Gondwana, linked to what are now South America, Antarctica, and India. When the continents began to drift apart, the forces unleashed reshaped the Sahara region into a basin of shifting rock and sediment. What's remarkable is that within these deep formations, scientists have found traces of ancient marine sediments, fossils of sea creatures that lived when this part of Africa was submerged beneath a prehistoric ocean. The Sahara, it seems, has been both sea and savanna, both cradle and grave of worlds long vanished. The fossilized remains of these marine ecosystems are extraordinary in their preservation. Layers of limestone reveal corals, mollusks, and fish from eras when tropical waters covered what is now an endless expanse of dust. The chemical composition of these fossils shows evidence of dramatic shifts in salinity and temperature, signs of turbulent geological ages when the Earth's crust heaved and the climate swung wildly between extremes. These fossils not only tell the story of an ancient ocean, but also provide data that help scientists model how ocean currents and climate systems interacted over millions of years. In essence, the Sahara's buried seafloor is a time capsule of the planet's climate memory. Equally astounding are the remains of prehistoric forests found fossilized deep beneath the desert. These petrified woods are unlike anything found elsewhere in Africa, with massive trunks turned to stone through the slow alchemy of minerals and time. Some of the trees date back more than 200 million years from an era before flowering plants existed. They reveal that the Sahara once supported towering conifers and ferns in a moist, temperate climate where dinosaurs and early reptiles would have roamed. The layers above these fossilized forests show how the land dried out in stages, each phase of desiccation marked by the disappearance of different species and the spread of sand. These findings have led scientists to view the Sahara not just as a region, but as a record of Earth's entire climate journey. The fossil forests and seas are the deep past. The river valleys and civilizations are the recent echoes. Each stratum of the desert's geology captures a snapshot of transformation, from ocean to jungle to savanna to wasteland. The sheer scale of change suggests that the Sahara has undergone repeated cycles of greening and drying, each one erasing the memory of the last until only the sands remain to tell the tale. Yet the story hidden beneath the Sahara is not only one of loss. Among the most recent discoveries are signs that deep within the desert's subsurface, geothermal activity continues to stir. Thermal imaging and satellite data have revealed hotspots and magnetic anomalies that may point to dormant volcanic systems buried beneath thousands of years of sediment. If confirmed, this would mean that parts of the Sahara still rest on active geological zones, capable of shaping the land anew in future millennia. These findings carry profound implications for energy and resource exploration. The ancient basins and fossilized river deltas beneath the Sahara have trapped vast reserves of oil, natural gas, and potentially even rare earth minerals. But beyond industrial interest lies a deeper significance. These geological formations are also perfect archives of organic material, preserved for millions of years under layers of sand and stone. The organic compounds extracted from these rocks could help scientists trace how early life forms evolved in response to shifting climates and atmospheric conditions. The Sahara's subsurface could hold not only the fuel of ancient life, but also the clues to its resilience. As research deepens, a new picture begins to form, one that connects the Sahara's buried landscapes to global patterns of evolution and migration. During its greenest epochs, the Sahara would have served as a crossroads between ecosystems, allowing animals and humans to move freely between sub-Saharan Africa, the Mediterranean, and the Middle East. The reanalysis of fossil DNA and tool fragments suggests that this corridor was crucial for the spread of species and technologies. When the desert dried, these connections were severed, isolating populations and driving evolution through separation and adaptation. The Sahara, therefore, was not only the cradle of movement, but also the architect of diversity. What makes these discoveries even more striking is the realization that they were hiding in plain sight. The desert's sheer size and hostility deterred exploration for centuries. Even with modern technology, mapping such a vast region requires immense resources and coordination. Yet every year, new revelations emerge, from buried river valleys the size of nations to ancient shorelines stretching across entire countries. Each discovery builds upon the last, revealing a coherent narrative of transformation that defies the simplicity of calling the Sahara merely a desert. Among the most evocative finds are the fossilized footprints of humans and animals that once crossed now barren plains. These footprints, preserved in hardened mud layers, capture moments frozen in time, families walking along the edge of an ancient lake, herds of cattle trailing behind, predators lurking nearby. Some prints belong to species that no longer exist, their existence erased by the relentless march of aridity. Each track is a silent testimony to a world where the Sahara was alive with sound and motion. The more scientists study the region, the clearer it becomes that the Sahara's climate cycles are tied to subtle rhythms of the Earth itself. Variations in the planet's orbit and axial tilt periodically alter the distribution of sunlight, changing rainfall patterns across Africa. Every 20,000 years or so, the Sahara alternates between green and desert phases, a pulse in tune with celestial mechanics. This revelation means that the Sahara's greening could return in the far future, when the orbital cycle once again brings heavy monsoons to North Africa. The desert may not be permanent. It may simply be resting between awakenings. In some regions, researchers have detected buried ice and permafrost-like layers deep beneath the dunes, frozen remnants of a time when water still seeped through the soil. These layers preserve gases, pollen, and minerals from ancient atmospheres, giving scientists the rare opportunity to study climate chemistry from thousands of years ago. Each core sample is like a miniature time machine, revealing the air composition, vegetation, and rainfall of forgotten centuries. Through this data, climate scientists can trace how the planet's natural systems responded to warming and cooling long before human influence began. As these explorations continue, scientists have also begun to uncover evidence of magnetic field reversals recorded in the desert's rock layers. The Sahara's magnetic history shows that Earth's field has flipped multiple times in the region's geological record, with each reversal captured in the orientation of iron particles within ancient sediments. This data helps refine models of the planet's geomagnetic behavior, offering insights into the shielding effects that protect life from cosmic radiation. The desert's rocks, in their silent magnetism, preserve a story of the Earth's deep interior and its restless energy. Meanwhile, biological discoveries continue to astonish. Fossilized remains of amphibians, reptiles, and mammals reveal species adapted to both wet and dry conditions, transitional forms that evolved as the environment shifted. In the sediments of ancient lakes, researchers have found fossilized algae and microorganisms that survived through extreme fluctuations of salinity and heat. Studying these organisms provides a rare glimpse into how life endures and adapts in hostile environments. It is possible that some of these ancient genetic lineages still exist today, hidden in microbial mats deep within underground aquifers. Another extraordinary revelation comes from isotope analysis of fossil teeth and bones found beneath the Sahara's surface. These isotopic signatures allow scientists to reconstruct diets, migration patterns, and even seasonal behaviors of prehistoric animals and humans. They show that early humans in the Sahara exploited a wide range of food sources: fish, plants, and grazing animals, indicating a complex society that adjusted ingeniously to shifting environments. The same analyses also reveal periods of famine and migration, painting an intricate picture of survival and adaptation. Further research into the Sahara's subterranean structures has led to the discovery of massive salt deposits, remnants of evaporated seas and lakes. These salt beds are not only geological wonders, but also chemical archives. Trapped within them are tiny inclusions of ancient water droplets, preserved for tens of thousands of years. Scientists can extract these microbubbles to analyze their composition, revealing the precise conditions under which they formed. Such analyses could refine our understanding of ancient precipitation, evaporation rates, and the mineral cycles that governed early ecosystems. In the heart of the desert, remote sensors have also detected vast networks of what appear to be buried canyons, ancient scars carved by rivers that predate human existence. These colossal channels run for hundreds of miles beneath the sand, connecting what were once major drainage systems. The scale of these features suggests that the Sahara was once home to one of the most extensive freshwater networks on Earth, rivaling the Amazon in size. The sediments within these channels still hold traces of organic material, waiting to be analyzed for clues about ancient flora and fauna. Even more mysterious are the unusual gravitational anomalies detected in certain regions of the central Sahara. These distortions hint at the presence of dense materials buried deep underground, possibly the remnants of massive meteor impacts or long-extinct volcanic systems. Some scientists hypothesize that such impacts may have played a role in triggering climate changes that contributed to the Sahara's desiccation. If confirmed, these findings would link cosmic events directly to the evolution of Earth's ecosystems, showing how extraterrestrial forces can reshape entire continents. Amid all this geological and environmental complexity, the traces of humanity continue to emerge. Stone carvings, artifacts, and tools buried in sediment reveal societies far older than previously recorded. Some stone circles and alignments uncovered under the dunes seem to predate known megalithic structures by thousands of years. Their precision suggests early astronomical knowledge, possibly calendars aligned with the solstices and equinoxes. Such discoveries indicate that long before recorded history, human beings were observing the heavens from what is now barren desert. connecting their lives to the rhythms of the cosmos. These ancient builders likely observed the cycles of the monsoon, timing planting and migration to the rise and fall of the rains. Their culture, erased by the advancing sands, may have passed its knowledge indirectly to later civilizations along the Nile and Mediterranean. The Sahara thus becomes not just a stage of natural transformation, but also a bridge in the lineage of human intellect and spirituality. Beneath its sands may lie the missing links between nomadic foragers and the architects of early civilization. In addition to human traces, paleontologists have uncovered skeletons of massive creatures once roaming the Sahara's plains: giant buffalo, antelope species twice the size of their modern descendants, and crocodiles capable of growing longer than buses. One of the most spectacular finds was the fossil of Sarcosuchus imperator, a prehistoric crocodile that could exceed 40 feet in length, once dominating ancient rivers of the region. The presence of such formidable predators confirms that the Sahara was once teeming with vibrant aquatic life. The sediments surrounding these fossils even show ripple marks and mud cracks, preserved as if the rivers had dried only yesterday. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on what scientists found beneath the Sahara? We want to hear from you. Thank you for watching and see you next time.